Hi, it's Jake Stimson here. So I'm just going to record my quick video going over kind of the process for this lab and what I learned. So we were tasked with actually creating the custom block or custom AXI block here. I wasn't actually able to get that to work because for some reason the code that was shown in the actual lab manual wasn't there when I actually opened up the RTL in the AXI block that you told us to use. Um, so I just, the principle of the lab was being able to connect the GPIO through the processing system, writing C code, and then sending data through the processing system back through AXI to the GPIO. So I was able to still achieve that just using pre-existing IP blocks. So you can see here, I used the AXI interconnect here. This is the final design after you told us to add buttons. For the initial design, you only really need the AXI peripheral because it has one master output. And then you can just connect that master output of the AXI peripheral to a single AXI GPIO block that you can see here. You can make them single channel or you can make them dual channel. So for the first part of the lab, I just had AXI peripheral connected to AXI GPIO, and then that single GPIO was taking care of my switches and my LEDs. And then I talked a little bit about this in my report, but you don't actually need to use a constraints file when you create a project in Vivado the way we created the project. So because we chose the Zybo Z7-10 board, in the IP integrator, we actually have this board section, and it shows you all these existing, they're pre-constrained on the back end to where you can just click on one of these things and it'll actually suggest like, oh, hey, to use this, we can give you another AXI GPIO block, and then it would add that to my design. So that's how I'm connecting the 4 buttons, 4 LEDs, and 4 switches to these GPIO. You don't need any constraint file when you're doing this block-based design. So then obviously from here, you generate the bit stream, and then from that bit stream, you do file, export hardware, and you need to include the bitstream to get your Xilinx support archive, like .xsa file. So once I have the XSA file, then I go here into my Vitis. So here is my final part 2 of the lab, right, that includes the buttons, the LEDs, and the switches. So here you can see because I have 2 blocks, I have to initialize 2 XGPIO objects in the top. Then in our main function, we have this init platform. This is just for UART and enabling the Xilinx print function, right? So this is why we have this at the top, so we can output to our PuTTY console. And then here we just enable our 2 different GPIO channels so that we're using GPIO initialize. And if there isn't a success here, if this fails, then we'll output this. If it doesn't, then we get the proper initialization printed to console. Then we'll set the directions. So here you can see that we're referencing GPIO 0. The LED channel is obviously just going to use this direction mask, which is the 0xFF, which because we have 4 bits, right? F is going to be 1111 for the 4 least significant bits. So that's why we're using 0x0F for all of these, right? We're just enabling turning on the 4 bottom bits of the 8 bits that we're selecting. Then this is just a quick test. I was using just a test that I was actually able to program the board. So this will output hello world. And then this is the majority of what's actually doing the work here. So we have a while loop that uses GPIO discrete reads on the first channel and the second, or the 0 and the 1 channel of GPIO to read the switches and the buttons. Then it'll write to the LED channel based on whatever was read into the switches, and it'll output to console. Jake Stimson's script has checked, and it'll output the decimal value of switches and the decimal value of buttons every second because we're sleeping on 1. So here I'll pull up PuTTY right here, and you can see this is actively going. So as I turn on and move around buttons on my board, you can see that these numbers are changing. The LEDs on my board are also illuminating, but that's something you can't see. And then as I press the buttons, right, I have the 4th position pressed. Now I have 2 buttons pressed. If I can press all 4 at once, right, we should be able to get the full F output. Yep, perfect. So thank you. I hope you can see everything here is working.